Hi y'all, today I'm back. I'm finally back. My semester is finally over, so I have more time to record myself and actually, just I have more time now to record myself. And I'm just gonna be doing LeetCode to help me prepare for my interviews. Uh, so I'm gonna do a bunch of binary tree problems, and yeah, I'll be posting more. So we're given the root of a binary tree, and we want to invert it. So first, we want to check if their node, if the root or their node we're given is even uh, valid. So if it's not a node or or, or the root, we just return null or none. Now we just want to swap the, now since our node is valid, we want to swap the left and the right child. And we do that by root dot left and root dot right equal, so we switch them. It's gonna be root dot left is gonna go root dot right, and left is gonna go right. Right is gonna go left. Root dot left. Next, now we swap them. Now we gotta do the same for for the child of the left and the right. And to do that, we just call self. So it's gonna be self dot invert tree root dot left. I'm gonna copy and paste this. Then root dot right. Then that's basically it. Then we just return the root, and that's gonna give us the inverted tree. I just like that. The next problem I'm gonna do is maximum depth of a binary tree, and this one is pretty simple as well. We just want to use DFS to traverse, I guess, the longest path, whether it's the left or the right side. Then we just return the max of whichever side is the highest. So for the left, it's gonna be self. We want to call it self. So self dot max depth of root dot left, and right equals self dot max depth root dot right. Then we can just return. Sorry, return. So at each level, it has a depth of 1. So we're gonna have to 1 plus max of the left and right, like that. I think, I don't know, maybe this might be a base case. So if not root, we return 0. Let's see if that will work. Yeah, it still works. Uh, okay. Then the next problem is if it's the same tree. Um, so first, we're giving two roots of a binary tree p and q, and we gotta write a function to check if they're the same or not. So I think this one has three conditions where if it's true. I think the first one is if if both of them are not, if both of them are null, then we want to return true because they're technically, the same. But if not p and not q, I return true. Now we move over the fact that it's null. If they're both null, then it's the same. But if one of them, for now, we gotta check if one of them is uh null while the other one isn't. We return false because they're not the same. So if P and not Q or Q and not P, we return false. And it's also false if they don't have the same value. So if P dot val does not equal Q dot val, then we return false. And it's pretty much sums up the three conditions. And now we just have to check the it's left and right child. So and we can just do that by doing return self dot is sync tree calling itself p dot left q dot left. I'm gonna copy this and p dot right and q dot right. Yeah, I think this should work. All right, that's all I'm gonna do for the day. I'll keep doing more. At probably tomorrow. I mean, I think for sure tomorrow. But yeah.